Okay. Step 1. Label things. If this is the right angle over here, then this is our hypotenuse. Let's say that's A, that's B. Calculate the length of the side of the frame FG. So that's from here to here. So Pythagoras' theorem is c squared equals a squared plus b squared. And let's rearrange this now to make b squared the subject. So we've essentially got to subtract a squared off from this side. And remember, all equations have to be balanced. What we do to one side has to be done to the other. So we end up with b squared is equal to c squared minus a squared. So here I'm going to skip a few steps, and instead of writing b squared, I'm just going to write b is equal to 6.2, that's our c over here, minus a squared, which is 4.4 squared, and square root of the entire lot. Okay, which gives us 4.3680 blah blah blah. Okay, now we're going to round this. Now they've rounded everything here to one decimal place. So we need to cut it off here. And the number after the line is 6, so we round up. So 4.4 meters to one decimal place. Okay, so that's the length. Calculate the angle the frame makes with the ground at FGH. Okay, so G is the center angle that is the center of the angle. So we want the angle here. FGH. Okay, so we've got our hypotenuse labeled. Let's just relabel this. Let's just eradicate all of this so to give us some space. Okay, so we've got H over here. Now the other two sides are in context or with respect to our angle over here. So that means that's opposite. That's the side that's opposite the angle. So we've got sine. S-O-H, so we've got O and H, so we're looking for sine. So sine of FGH. Let's make sure that that looks like our angle is 4.4 over 6.2. So angle FGH is equal to sine inverse of 4.4 over 6.2. Now, when you put it into your calculators, make sure it is in degrees. Otherwise, I think sometimes it's normally in radians, and if it's in radians and you're looking for degrees, it's going to look like some really weird number. Well, when you're expecting degrees. So when you put it in your calculator, make sure you put it as sine inverse, and then you put your brackets around 4.4 over 6.2. Okay, and we should get something like 45, somewhere around 45 degrees. 45.2 degrees. Okay, 1 decimal place. Okay. And then that's part A answered. Part 2, we are going on to some balloons here. So let's just eradicate this. Balloon A is tied to the ground by the rope labelled TA. The wind is strong and causes the rope TA to make a straight line. The balloon is 40 metres above the ground. The rope TA makes an angle of 26 degrees with the ground. Calculate the length of the rope TA. Okay, so they want the length of the rope. So T is over here, our A is up here, and our G is down here. This is a right angled triangle, so this is the hypotenuse, or C in terms of Pythagoras theorem as you know it. So we've got C squared is equal to A squared plus B squared. We're only given the length of one side and we're given an angle. So what we should do is actually label this for our trig function. So that's the opposite. That's the hypotenuse. It looks like it's another sine to me. So it should be sine of 26 degrees is equal to 40 meters over the hypotenuse. Okay, so we're looking for the hypotenuse. Let's rearrange this. The h is on the bottom, so essentially the sine of 26 degrees and the hypotenuse switch places. So we end up with h is equal to 40 over sine 26 degrees. Let's just stick that into our calculator. 40 divided by sine of 26 degrees, which should give us 91.2 meters. On dp.